Okay, in this video, we're going to look at some probability questions with rolling two die, and I included a chart here for us to help visualize as we go. There are a lot of problems here, and I didn't feel like cutting them all out individually, so we'll look at number 13 and um, actually just 13, maybe like A and B. There's a lot of problems there, and then 16, A, B, and C, and 17 and 18. So two dice are rolled. Find the probabilities of rolling the given sum. So the probability, um, there are different ways of writing these, but one way, like since we know the scenario, we could just say the probability 2. So this thing, the event of where the sum is 2. Okay, or if you wrote probability sum is 2. That works too. Usually, the simpler the notation, the better. So, P of 2. Well, there's only one possible way to do that, right? If I roll two die, they both have to be 1. So that very upper left, if they're both 1, and there are a total of 36 possibilities, right? 6 um, combinations for each row there. So the probability is 1 out of 36. And really quick, I know it doesn't ask, but I wanted to throw in odds as well. Some authors teach it a little different, so I wanted to throw out my way. So the odds in favor of the sum is 2. Okay, that means like what are the odds that I do roll a 2 versus um, the probability I roll a 2 versus the probability I don't. Okay, I like to do this like this. There is one way that I can roll a 2, and there are 35 ways I cannot roll a 2, right? So the odds in favor, here are the number of ways I can in favor, and then the number of ways against. If you compare their probabilities, the denominator would always cancel, like 1 over 36 to 35 over 36. So the 36s would cancel anyway, so that's the way I like to do it. Okay. Probability the sum is 4. All right. Now looking at the column over here, we have 1, 2, 3. 3 ways. We could get a 1 and 3 or a 3 and a 1. Those are different, right? Because we're rolling two die. But if they're both a 2, there is no way of switching that up. So we have 3 out of 36 or 1 out of 12 after reducing. All right, so again, the odds, let's go ahead and do that as well. And in favor, again. So once it's reduced, I have 1/12 versus 11/12, so or 1 to 11. Okay, there, out of the 12 ways reduced, I have one way that I could roll that sum of 4, 11 ways I could not. Now I know it's out of 36 in all, but using the reduced form, I don't have to worry about reducing odds. See, if I did the odds of 3 ways versus the 33 ways, right, the unreduced form, they both are divisible by 3. So when I divide by 3, I get the reduced version anyways. Okay. 16a. The probability that the die sum is not more than 5. So not more than 5 would mean I still include 5, right? But not more than that. So looking at, whoops, thought it was on highlighter there. Yep, green is fine. Okay. The 5 is here, kind of follows that diagonal, but then we could also roll 4 or 3 or 2. So we need to add all of those up, not more than 5. So I'm going to say P, that the sum, we'll just call the sum x, is less than or equal to 5. Okay, and we get 4, 7, 9, 10 out of 36, which reduces to 5 over 18. Okay, and again, odds. We can use this reduced form. That would be a 5 to 13. All right, not less than 8. So not less than 8 would mean it has to be 8 or greater. Right? If it's not less than 8, then 8 is not less than 8, 9 is not less than 8, and so forth. So take all the combinations up there that are 8 or greater. We have 12, we have 11, we have 10, we have 9, and we have that row of 8. So we have 5 plus 4 plus 3 plus 2 plus 1. Over 36. Okay. And that's 9, 12, 14, 15 out of 36. But both of those divide by 3, so 5/12. And once again, we'll throw in the odds in favor, 5 to 7. By the way, if it said odds against, we'd simply switch these around, 7 to 5. Okay, between 3 and 7, exclusive. So exclusive means we are not counting 3 and 7. So the probability that x is between 3 and 7, which means probability of the sum is either 4, 5, or 6. 4, 5, or kind of hard with that thicker marker, but we could see it. Right, here's the 4s, the 5s, that's 7 of them, and the 6, 8, 9, 10, 11, 12. 12 out of 36. Or 1/3. I switched colors there, that's okay. Okay, 1/3 or a 1 to 2. Trying to stay consistent here, 1 to 2 odds. All right, for 17 and 18, I included the union rule for probability here, and I wanted to explain that for a second. That's why I wrote it. In order to find, here's that, the probability of two events combined with an or, right? A union is equivalent to saying, that's a union sign. That's like saying or. So the first die is 3 or the sum is 8. If we look where the first die is 3, we have those 6 combinations. So the probability of E, okay, the probability the first die is 3, so we'll just call that E. I'm not going to write it out. Okay, probability of E, I know is we have 6 ways out of the 36, and then the probability of F, so we're going to call F the sum is 8, because that's or, right? Or the sum is 8. We have this one, this one, this one. Notice this one right here gets counted twice. All right, and that's this. Oh, and I wrote it wrong. Minus the intersection. Whoopsie. Anyways, so we had 5 out of 36 ways where the sum is 8, and then we subtract that 3-5 count because it got counted twice. Okay, that is what this union rule for probabilities is saying. Go ahead and add the probabilities, but subtract the intersection because you would have counted it here and here. Okay, we don't want to count twice. So that would be 10 out of 36, and we reduce to 5 out of 18. Now, looking at it differently, like, all right, if I have all my outcomes here, right, we don't always need this rule. If I have all the outcomes here, all the ones that start with 3, I'm going to go ahead and circle, and then go through all the ones that sum with 8, I will circle, and I'm not going to circle that one, that 3-5, because I already counted it. Right now I could simply just add up all the combinations, and I could see it's 10 out of 36 without having to use this rule. All right, one more. 18. The second die is 5, or the sum is 10. Second die is 5, would be all of these, okay, or the sum is 10, okay, or we have a 10 here, we'll have that one, right, and a 10 here. So if I simply do it without this probability rule, because this one is easier to just list all the possibilities I have 8 out of 36. That reduces by 4 on each, so that is 2/9, and I'm done. If you use the probability rule, we would have had the 6 here, plus the 3 here, and then subtract the 1, because that was counted twice, all out of 36. And again, that results in exactly what we had.